Hi dear students and viewers, welcome back to our channel Anvinay Kumar Basics of Physics. Dear students, in this video I am going to explain about the what is gravitational potential energy and how we can derive the expression for gravitational potential energy in case of two particles which are separated by some distance. So dear students, before starting the lesson, my request is in my channel I am uploading the all videos of intermediate first year, second year and MSET NEET videos also I am going to upload. That's why you can subscribe my channel and inform my channel about the content what I am explaining the channel to your friends also. Okay, without late I am going to the topic. Define gravitational potential energy. What is mean by gravitational potential energy? The amount of energy required in bringing a massive body from infinity to the at a point in the field, that should be what we call gravitational potential energy. The amount of work done in bringing a massive body from infinity to the at a point in the field, that should be called gravitational potential energy. Children, we have some idea about the magnetic field. What it is that the space around the magnet which is in its influence, that should be called magnetic field. In the same manner, every massive body have certain area around itself, that should be in its influence of gravitational force. Then that particular area occupied by the particular body is what we call gravitational field. For example, this is the one object, and this is the space around the object. So here this is the space around the object. In that space there is some gravitational force because of this particular body, then it is called gravitational field. That means what? In that particular area only it will show the force of attraction or gravitational force. So now children, now we want to bring the body from infinity to the at a point in the field, So to bring the body from infinity to the at a point in the field and against the field, that should be what we call here gravitational potential energy. So gravitational potential energy is given by the formula minus Gmm by R minus Gmm by R. Here capital M is the mass of the earth, small m is the mass of the body. If you can take in particles, we will write U is equals to energy at the point P. So you have to carefully observe the diagram. This is the earth of mass capital M, and now we
Please
want to
subscribe
bring
my
the
channel.
another body of mass small m from infinity to the point P. So here there are 2 points in the gravitational field. One point is P, and there should be a distance of small r from the center of the earth, small r at the center of earth. Here center of earth is nothing but center of mass. The entire mass is located at the center of the earth only. That's why all the distance should be taken from the center of the earth. So here P and A are 2 points in the gravitational field of earth, and they are at a distance of small r and small x. And now here A is at a distance of x and P is at a distance of r. Now we have to find out the gravitational potential energy at the point P. For that, here now children, at the point A, the force acting between earth and body is given by universal law of gravitation. What it is? F is equals to Gmm by x square. What we know? F is equals to G into m by r square. This is the formula. Universal law of gravitation. But according to that, what right? Here distance what is taken here? This is the body of mass m here now. and it is a distance of x. Then what to write? F is equals to gmm by x square. This is the amount of gravitational force between the two bodies at the point A. At the point A. Now, dear students, if you want to move the body from A to B, for that we have to do some work. We have to do some work to move the body from A to B. The displacement is dx. So what we know, work is equals to force into displacement we know. So in the same manner, here there is small amount of work done to move the body from A to B, that is given by F into dx. dw is equals to F into dx. From equation number 1, what is F? From equation number 1, what write? dw is equals to F into S means what? F into means what here? F is what? Gravitational force. How many was given? G by x square dx. So this is the small amount of work done to move the body from A to B only. So actually, what is our aim? To find out the work done from infinity to the point B. That's why for total work done, to move the body from infinity to the point P. So we have to integrate the equation like this. Integral dw is equals to integral, here what you have to say, x is equals to what? Infinity to the x is equals to r, and gm by x square dx. Clear? So g, universal gravitation constant, capital M, mass of the earth, small m, mass of the body, and x is what? Distance is constant here, but while we are integrating that one, distance is changes. Okay, very good. So that's why here after integration what we get? W is equals to g constant, m constant, small m also constant. The variable thing is what? 1 by x square dx. While we are taking from infinity to the point B, the distance will be changes. That's why here what write? W is equals to m integration 1 by x square dx we will get. So for that we have to do the integration. So children, I think you have idea about the formula in integration. That is what here that equation should be written as W is equals to gm into the 1 by x square dx. 1 by x square dx can be written as like this. X to the power of minus 2 we can write. X to the power of minus dx. Limits are infinity to the r. Clear? So now we have one formula is there, that is what? X to the power of n dx. Integral x to the power of n dx, and limits are a to b. Then what to write? Here x to the power of n plus 1 by n plus 1 is the formula, and limits are a to b, and we have to substitute the first upper limit b to a. Where is the x? There you have to substitute the upper limit. B to the power of n plus 1 minus a to the power of n plus 1 by n plus 1. This is the formula we are going to use. Integration x to the power of n dx is equals to x to the power of n plus 1 by n plus 1. In this one variable thing is x. There we have to substitute the first upper limit minus and lower limit a. So b to the power of n plus 1 minus a to the power of n plus 1 by n plus 1. This is the formula for that one. Now we have to apply the same formula for that equation. Then obviously we will get the total work done. Children, we need some space. That's why I am arranging this one. Then what write? W is equals to g m. So what you have? Like x to the power of n plus 1. That's what you have. In the place of n, what you have? Minus 2 is there. That's what I write. X to the power of minus 2 plus 1 by n plus 1. Again minus 2 plus 1. And limits are what? R to infinity to the r. Then W is equals to what, right? Gm into x to the power of minus 2 plus 1 means what? Minus 1. Minus 2 plus 1 means what? Minus 1. And limits are r and infinity. Here W is equals to, he will write gm minus of gmm of 1 by x, we can write 1 by x r infinity. That's why here what right? W is equals to minus gmm by r into, first you have to substitute upper limit, 1 by r minus 1 by infinity. So 1 by infinity value is what? 0. Then what you get? W is equals to minus gmm of 1 by r minus 1 by means what? 0. Then what you get? W is equals to what you get? W is equals to minus gmm by r. Capital M is there and small m is there. It is the r. This is the total amount of work done. For what? To move the charge from infinity to the point P. Okay. So now this amount of work done is nothing but children. So what we got total work done? Total work done is what we got? S. W is equals to minus gmm by r. Here minus represents the nothing but force of attraction. So here children, what we know, what I am telling, work done is equals to this amount of work done in the form of gravitational potential energy. Gravitational potential energy. Therefore W is equals to what right here, nothing but U. U is equals to minus gmm by r. So here what is r? R is distance from center of earth to the selected point P, and this r is so greater than capital R. What is capital R? Radius of the earth. Small r is greater than the capital R. So children, from this equation what you can say that Gu is equals to minus gmm by r, we are saying that. So for example, if you can write U is 0, what is U here? Gravitational potential energy. When U is equals to 0 is possible if r is infinity. R is infinity. That means the point is very far off from the earth. Then U value becomes 0. So children, this is the amount of work done, nothing but gravitational potential energy. What is? U is equals to minus gmm by r. If you can take the two particles, one is having mass m1 and next one is having some mass m2, then the gravitational energy is given by the minus of gm1 m2 by r. So this is about the children universal gravitational potential energy.